Well, question 30 asks to find the maximum rate of change of the function and the direction at which you have the maximum rate of change. Very well. What is your function? Your function is f of x and y equals to square root of x squared plus 2y, and the point is 4 and 2. This is your point. So maximum rate of change. Maximum rate of change. Remember, we talked about gradient and we talked about the magnitude or size of the gradient. And we say that for a function, if we find the gradient of the function and take its size, it actually gives us the maximum rate of change of the function. So let's find the gradient of the function. F of x is equal to, so with respect to x, you have 2x divided by 2 square root of x squared plus 2y, comma, with respect to y, you have 2 divided by 2 square root of x squared plus 2y. So of course we have to evaluate that gradient of f at the point 4 and 10 is equal to, so here 2, cancel out 2 and 2, you get 4 divided by square root of 16 plus 20, comma, 1 divided by square root of 16 plus 20. So gradient of f at 4 and 10 is equal to 4 divided by square root of 36, which is 6, and 1 over 6. So you have 2/3 divided by 2/3, and the second fraction is 1 over 6. Very well. So since it's just a vector, you might say, hey, I want to multiply this vector by a scalar like 6 and simplify this gradient vector as well. So let's find the magnitude first. The magnitude of this vector is equal to square root of, so here you have 16 divided by 36 plus 1 divided by 36. I'm going to write it this way so I get the exact same denominator for both of them. It makes it easier for me to actually simplify this. So you get square root of 17 divided by 6. Very well. So what is the direction? The direction is in the direction of this vector. And this vector, so here you have 2/3 and 1 over 6. If you multiply by scalar like 6, you get 4 and 1. So this is your direction. You can get rid of the denominators. It's easier to actually have a vector written in a nicer form like 4 and 1.